Now we talk about F-test for variance. So variance is a measure of volatility of the stock. So say you're given two normally distributed populations, and these two populations have variance sigma 1 square and sigma 2 square. So we want to test whether these two variances are the same. So for this purpose, you have a test called an F-test. The null hypothesis is that the ratio of these two variances, sigma 1 square and sigma 2 square, is 1. So say the sigma 1 square comes from a population X and the sigma 2 square comes from a population Y. So once you run the F-test, it will spit out a confidence interval. So this confidence interval means that 95% probability interval. And if this interval contains this 1, then you say that these two variances are statistically equal. Otherwise, they are different. So they say this X is a sequence of normally distributed random variables. So this distribution is nothing but percentage return on stock X. So this is 1.2%, 3.1%, minus 1.3%, 2.4%. So notice I'm not using stock prices, but I'm using the percentage return. I cannot use the stock prices because stock prices are not normally distributed, but their return is normally distributed. So the assumption always is that the return on the stock prices is normally distributed. Similarly, you have Y. Again here, you have normal distribution of the returns. So you run a variance test. This is the F-test. So all these are set of commands which you run in R. And this is the variance of X and this is variance of Y. So once you run this test, you will get a confidence interval. So for these set of values, you get this confidence interval 0.13 to 3.25. So this contains 1. So if you compute variance of X, that is 17.5. and variance of Y is 26.82. So mathematically these two are different, but statistically they are same, because the confidence interval contains 1. So you cannot distinguish between X and Y. So another example, so you have say stock A and stock B, and these are the set of values which are percentage return on the stock. So again you run the set of tests and you get a confidence interval. So this confidence interval now does not contain 1. So you can say that this 8.1, which is variance of X, is statistically different from 43.73. So these two are significantly different. These two are not significantly different, so you don't have to worry much about it. So now you can have an automated trading strategy which is based on this. So you keep some stock as benchmark. So you always keep stocks as benchmark because the market could get volatile, the market could go up, the market could go down. So you cannot have a constant number. What you can have is a constant benchmark of a stocks. So these stocks in your portfolio should follow, so the stocks in your portfolio should follow these benchmark stocks. So if some stocks show very high volatility compared to your benchmark, so say A is your benchmark and B is the stock which is in your portfolio. So if B shows high volatility compared to A, then you divest B and replace B with say some other stock C which shows similar variance as compared to A. So that is, you run the variance test and see if the confidence interval contains 1. If it contains 1, you keep the stock, otherwise you throw it out. And this you can do an automated trading strategy for this, and you could run the data of the entire stocks in the market, and your machine can pick up the stocks which you want to prefer compared to your benchmark. So you start by opening the new script. Go to File, you open a new script, then you copy paste everything which is in the description of the video. To run the test, so we are running the F-test. This is called variance test. So we are testing whether the variance of X is same as variance of Y. So what you do is you select everything here and then you hit this run button. So once you run the selection, you get this variance test. So these are the two sequences we ran, x and y, and you can see this is the confidence interval from 0.13 to 3.25. so this contains 1. So you can say the variance of x is same as variance of y statistically. So notice that variance of x is 17.5 and variance of y is 26.8. so these two are statistically same. Mathematically they are obviously different. Now we run another data set. You're given a and b, so we want to run these two. So select them and hit the run button here, and then you get this. So you have data as series a and b. This is data as a and b, and this is your confidence interval 0.0372 to 0.925. And notice that this does not contain 1. So statistically this variance of a, which is 8.10, is different from 43.734. so a and b have different variance.